Hello and welcome to this lecture where we're going to be looking at oscillator A and oscillator B in this main oscillator tab. So both of these oscillators are actually identical. They have identical settings, but of course we can use different settings and blend the sound of the both oscillators together. If you're just using one of the oscillators though, I do recommend turning off the other one as it will use up more CPU power. So on oscillator A here, if you see where it says default, if we click on this, we'll have a drop-down menu. So here we can choose different wavetable libraries: analog, digital, spectral, user, where you can put your own custom-made wavetables, and vowel. Okay, let's go up to analog, and I'm just going to choose basic shapes. So this just has the basic shapes you'd expect, and the default one loaded is a simple sine wave. If you actually click on the wavetable display here, you can swap to 3D view. So this will show us the different wave shapes in the table. You'll see on the side we have this number. At the moment it's on number 1. So this shows us the current frame selected. If we go over to this dial here, this is wavetable position, and we can scroll through the different wavetable positions, and you can see the number here change when we scroll through. So now it's on 5, 6, and 7. So there's 7 different wave shapes in this table. The yellow line here obviously shows the current one, and we can click on this 3D view again to go back to the previous display. You'll also notice in the top right of this wave we have a small pencil tool. If we click on this, this will open up the table editor. So this actually allows us to have a lot more controls of our wavetable. We can go back to the previous window by just clicking this X in the top left, and of course we can go back to it again by hitting this pencil tool in the wave. Before we really explore the wavetable editor though, let's go back to this main tab and just have a look at some of the settings down here. So here we have a unison voice option. So we have a maximum of actually up to 16 different voices, and you'll notice when we click and drag up or down that these lines will appear or disappear. Higher voices, however, will use up more CPU power. So I've just selected 5 voices, and to the right we have this detune dial. So this actually adjusts the tuning of the different voices. So when we move this detune dial over, you'll notice there's more space between the voices, and when we decrease this dial, you'll notice the space gets tighter. So this represents how far apart the tuning is from each other for each of the voices. So when detune is on 0 and all of these lines line up, that means all of the voices are tuned exactly the same. The detune dial also spreads the voices across the stereo spectrum. So let's just have a listen to this basic sound. I'm just going to drop the detune all the way down and just play a chord. And then I'm going to increase the detune and play the chord again. Obviously you can hear this detune dial really does affect the tuning and the sound of these different voices. Okay, going along we have blend. You'll notice when we increase blend, this yellow line will actually decrease. And when we drag blend all the way down, the yellow line will increase and the green lines will go down. So this middle yellow line, this actually represents the first voice, and the green line is the other voices. So with blend, you can make the first voice either louder or quieter. And you can also make the other voices louder by putting blend up. So let's just put blend all the way down, so we're going to hear mostly the first voice. And let's just increase blend. And obviously now we can hear the other voices blended in with the first voice. So let's just drag unison down to 1. And you'll notice that detune and blend don't actually do anything now because we only have one voice. So detune and blend will only work when you have more than one voice. Okay, going along we have phase. Before we look at this, let's just put the random dial down. So with this phase dial, we can set the initial phase of the waveform. So all the way up at max, notice here a little message will pop up saying phase memory. So this basically means that phase will continue where it was last left. You'll notice when we move this phase dial up or down, this yellow line will change position on the waveform. So it's going to set the initial phase of the waveform. So it's going to play from the start of the waveform here, the middle of the waveform here, and the end of the waveform here. This can be quite difficult to hear just with one oscillator. We really need to blend it with another one to hear the difference of where we set this initial phase. Okay, let's just turn on oscillator B, and if we go over to menu, we can actually copy oscillator A to oscillator B with this setting here. And now oscillator A and oscillator B have identical settings. So both of the phase dials are at the same point, so we're not actually going to hear any difference right now. Let's just put the detune down. Okay, so now we can't hear any phase difference. Okay, let's just change the detune, and I'm going to change the position of the initial phase. And now we can hear some phase between oscillator A and oscillator B because they do have different starting points or initial phase on these waves. Okay, we also have this random dial here. So this will actually add some random polarity shift. So we can actually see the amount of phase change in this waveform here with these yellow boxes around the line. And we can do this with either oscillator or both oscillators. So this will add some randomness into the initial phase. So it's similar to actually changing this phase dial on every single note. However, the random dial will do this automatically for you. So let's just turn off oscillator B now, and let's just have a look at this wavetable position dial in oscillator A. So when this dial is all the way to the left, it will show us the first wave. However, with this basic shapes, we only actually have 7 different waves. If I just click on this drop-down menu here, go to analog, and let's choose a more complex one. How about this one here? PWM Reso. You'll notice here, we have a lot more. We have 208 different waves. We can play a chord and just scroll through them here. So you actually see this wave morph and change. And we'll look at creating this in a future lecture. But like I said, this has a lot more waves than the basic shape, which just has 7. However, all this is really doing is just morphing between one wave and another. And if we click on here again, we can see the 3D view, and we can see this morph. We can have up to 256 different waves. So let's click on another one. Let's go to digital, and let's go to prime. And here we have 256 different waves. We can click again. So this wave shape is a lot more complex than obviously the basic shapes we were working with before. However, the basic shapes is a good one to start with because we're just going through the basic wave shapes. Okay, going along, we have this option here. So this is actually for waveform warp. So if we click on this, you'll notice we have this drop-down menu with a load of different warp options, and we're going to look at these in a separate lecture. Okay, and going along, we have the standard pan and level controls. And we have independent panning and level control for each of these oscillators in this main tab. And you'll notice above the wave here, we have a few different pitch controls. We have octave, which will obviously increase or decrease by 1 octave. And then we have semitone, where we can tune this either 12 semitones up or 12 semitones down. And then going along, we have fine tune, where we can tune this 100 cents up or 100 cents down. So the difference between semitone and fine tune is the semitone will tune this in a step-like motion between each semitone, and we can get smoother tuning with fine tune, a more gradual tune. So if you want to use an LFO on the tuning at some point later on, and you want a more gradual change, maybe fine tune could be more useful. However, if you want your tuning to change one semitone at a time, maybe you could use the LFO to control the semitones. We'll look at LFOs later on. I just wanted to give you a quick example of the difference between semitone and fine tuning. And going along, we have coarse pitch. So this allows us to transpose the pitch without actually snapping to semitones. So this can be useful with modulating with LFOs as well. And this allows us to actually transpose either 64 semitones up or 64 semitones down. Like I said, we'll look at modulating with LFOs later on. I just wanted to give you an overview of these main oscillators in this main oscillator tab. So that's the end of this lecture. I hope you found it useful. In the next lecture, we're going to be looking at the sub and noise oscillators.